Thank you for waiting and joining. Good morning and good afternoon, ladies and gentlemen. Welcome to the 13th Asia-Oceania AOGEO Symposium. I am Masatoshi Kamei of Restic. I'm very honored to be the MC of this symposium. Before officially starting the symposium, I have some notes for you. Because of COVID-19, we hold AOGEO Symposium online for the first time. It is indeed a big challenge for us to connect hundreds of participants remotely, and we made a very good symposium for you. We have 3 days program at only 3.5 hours per day. So I would like to express my gratitude to co-chairs and members of each TG who kindly had web meetings beforehand in order to shorten the symposium program. As for logistics, I kindly ask all the participants to set your camera off and mute your microphone during the symposium. When you have any questions and comments, you can use Q&A function of Zoom webinar system. You can click Q&A button at the bottom of Zoom window, and you can type questions and comments into a message window anytime. However, if you join as a panelist, you can't use that function, but you can use raise your hand function. So when you have questions or comments, you can use raise your hand function, and when the chair gives you the floor, you can make any comments. For speakers, kindly unmute the microphone and set your camera on by yourself when you speak. And if you have PowerPoint slides, our technicians will share and operate for you. Now, I'd like to start AOGEO Symposium. First of all, let me invite Mr. Hidehiro Mitani, Parliamentary Vice Minister of Education, Culture, Sports, Science and Technology, Japan, for opening remarks. 三谷政務官、よろしくお願いいたします。
I am Mitani Hidehiro, Parliamentary Vice Minister of Education, Culture, Sports, Science and Technology at MEXT. Today, I am very pleased that MEXT is able to hold the 13th Asia-Oceania Group on Earth Observation Symposium with support from the AOGEO Secretariat. On behalf of MEXT, I would like to thank all the participants at this symposium and to make a few introductory remarks. We live in the Asia-Oceania region, which is home to 2/3 of the world's population and blessed with abundant natural resources. But at the same time, our region is vulnerable to natural disasters and global climate change. Addressing these issues is essential for the inclusive growth of our region. Japan highly prioritizes these global environmental issues under the leadership of Prime Minister Suga, who set a new goal of zero emissions and achieving a carbon-neutral society by 2050. Japan is now taking proactive steps in various fields to realize the goal of reducing greenhouse gases. This symposium has evolved as an important platform for researchers and practitioners active in this region to exchange information through in-depth discussions under thematic task groups. These discussions contribute to finding solutions through the use of Earth observation data in response to the common challenges of this region. The theme for this symposium is enhancing the well-being of people in the Asia-Oceania region through Earth observations in the face of COVID-19 impacts. Design and implement future steps for Earth observation to realize global agendas, that is, international policy linked to the geo-engagement priorities. Through the discussion at this symposium, I hope that we will be able not only to reconfirm the efforts of GEOS in the Asia-Oceania region, but also to expand cross-sectoral coordination and cooperation, which will further promote activities to address global challenges using Earth observation data during and beyond the COVID-19 era. Before closing my remarks, I would like to express my appreciation to all the experts and scientists of the Asia-Oceania GEO, the GEO Secretariat Director and the Secretariat staff, as well as to the organizers of this event. I hope your discussions at this symposium will be very fruitful. Thank you very much.
Thank you very much, Mr. Mitani, for the remarks. Now I'd like to invite Dr. Gilberto Camara, Secretariat Director of GEO Secretariat. I'm sure he's online. Gilberto,
yes.
The floor is yours.
Thank you so much. So, good day to everyone. And my thanks are to the MEXT from Japan for organizing the 13th Asia-Oceania Symposium. I, from the point of view of the Group on Earth Observations, it is an enormous pleasure to see the meeting, in this case virtual, of important countries, member states, and organizations of the Asia-Oceania region, where we are going to discuss very important themes. The organizing committee selected the linking with statistics with SDG, capacity development in times of COVID, and the Pacific Islands area. It's very important that you are able to meet virtually, because for many reasons, the Asia-Oceania region is absolutely key to GEO. First of all, you have the most, the global population. You also have the most scientific output currently. So the most of the science related to Earth observations is now produced in this region, surpassing areas such as Europe, if we look at numbers of papers produced. You also have shown the world a lesson on how to deal with the pandemic, insofar as your countries have been much less affected by the pandemics than countries in Europe, United States, not to mention South America. So that's also an important lesson in the Asia-Oceania capacity for organization, diligence, and community unity, which is an important lesson to all of the world. You have, of course, worked in a lot of activities which are beneficial to GEO. There is important contributions from Japan, from China, from Korea, from Australia, from Vietnam, from other countries in the GEO activities. I think I would like specifically to highlight that, of course, the pandemic has affected some of the plans that were importantly announced in the last plenary that was online in Canberra, where we had important announcements by Japan and by China concerning the availability of open data. Of course, it's known that the pandemic affects these, so we know that in the recovery now that you're taking and with your fantastic actions to fight the pandemic, you are now perhaps in a position to retake these activities and to bring them to fruition and to make this data available. It's important to note that some of your countries are including now, they are reaching out to others. So I'd like to particularly highlight the effort of Australia, who has been central to the important activities on the dissemination of technology related to open data cubes, which are now part of the Digital Earth Africa initiative. So Australia is to be commended by its spirit of collaboration across continents and for making a fantastic work on data cubes. We are, of course, eagerly awaiting for the important contributions for next launches of satellites, which will come in the next years from China, Japan, Korea, and other countries, which are absolutely important to make data available. So we think clearly that your community is not only a key player in terms of regional outreach, but you also have shown to be capable of reaching out to other continents and to serve as a model in many aspects to other places and to other parts of GEO. So we hope you can continue, and we hope that some of the expectations we had in Canberra that were delayed by the pandemic can now, with your recovery, come back with the availability of open data as we had expected. And I think this is an enormous honor for the Secretariat Director to be here today with you and to commend you for the fantastic work you're doing and this important work of joining the community, and wish you a very, very good discussion on the topics you have chosen, but also in the discussions that have to do with the country reports and discussion about the working groups. Thank you so much. Arigatou gozaimasu.
Thank you very much, Gilberto. Thank you for the very positive message. Definitely, we are overcoming this pandemic. So before we move on to the country report session, I'd like to ask Dr. Ando to introduce scene settings of this symposium, including background, purpose, important points. So let me invite Dr. Kentaro Ando, who is AOGEO Coordination Board Co-Chair from JAMSTEC.
Thank you. Thank you very much, Kamei-san. I'm Kentaro Ando, one of co-chairs of AOGEO Coordination Board, and also coming from the JAMSTEC, Japan. It's my great honor to talk about scene setting in the beginning of this important symposium. We are facing global environmental challenges. So either PowerPoint is working? Okay, thank you. So we are facing the global environmental challenges through the regional changes and challenges at local scale for sustainable development, disaster risk reduction, and mitigation and adaptation to climate change. While considering the global concerns, we are also consider that there are regional commodities and differences or regional context. Therefore, regional coordination and collaboration by inclusive communications are crucial for the community to tackle the challenges across the thematic areas. By enhancing cooperation between regional GEOs and work program activities with the convening powers of GEO, the global community could work together to meet a shared agenda such as SDGs, Sendai Framework, for disaster risk reduction, and Paris Climate Agreement. In the AOGEO region, we have complex geographic characteristics and have large population in the region. The impact by climate change is huge, and various kinds of disasters occur frequently. Economic growth rate in this region is generally high, but in some places, infrastructures are not well developed to promote from natural disasters. Due to these reasons, we have strong demand to monitor environmental changes and risk monitoring. AOGEO is cooperating to strengthen comprehensive ability of Earth observation and applications in the regions, and wishing to cooperate with global GEO to address the global issues. This is the structures of AOGEO. We have AO caucuses by GEO principal from AOGEO member states. And below the caucus, we have coordination board by the members countries. Below the coordination board, there are 12 task groups to work for their own purposes. Recently, we have developed integrated priority studies project focusing on Mekong, Pacific Islands, and Himalaya. Data systems are crucial for GEO and AOGEO. We also discussed about data system during the symposium. We have now 2 forums. One is symposium, and the other is workshop. The symposium will provide opportunity to all task groups to discuss and summarize their activities. Also to discuss cross-cutting issues across the AOGEO and decide our future directions. Workshop will provide opportunity to develop our capacity in our AOGEO regions. During the symposium, statements will be made, which include our contributions to GEO's 3 priority areas and our future plans of all task groups and capacity development from the workshop. Looking back our history, AOGEO has started in 2007 by the name of GEO's AP Symposium in Tokyo. The symposium has been held mostly in annual basis, and every 2 years in symposium was held in Japan and other places overseas of Japan. In 2018, we have started the series of workshops focusing on capacity development by the strong support of China. Last year, 2020, we had the 3rd workshop in a hybrid style at Changzhou and online. In most of task group, we have strong link with global activities and the GEO. The styles of linkage will change case by case, but it is important to support each other for better development of activities in each discipline. For example, AWCI has strong link with GeoGlow and also DIAS. APBON has to GeoBON, etc., etc. On the uniqueness of GEO is cross-cutting challenges, and in AOGEO, we also have been challenging cross-cutting issues. At present, we have 4 major challenges. First one is contribution to GEO engagement priorities, which are SDGs, Paris Agreement, Sendai Framework. Second one is integrated priority studies, IPS. Third one is capacity development. Thanks to China, we could have been developing our capacity engagement new users, in particular from next generations. This should be one great contribution recently from AOGEO. Fourth one is very newborn challenges based on Canberra meeting. Based on Canberra statement, GEO developed Pacific Island Advisory Group. In this session, in this symposium, we will discuss possible cooperation between PIAG and AOGEO. This is number 8, I think, slide. This is our practice by each task group to check, confirm, consider how AOGEO activities are linked to GEO's 3 priority areas. As you see, all tasks contribute more or less to 3 priority areas. These scores themselves are not important, but doing this practice itself is important for each task groups to confirm current positions and to consider future activities. So next slide, please. As I mentioned, recently we have started AOGEO integrated priority studies as one of cross-cutting activities. We have selected 3 regions: Mekong River Basin, Pacific Islands, Himalaya Mountains, to cover from high mountains, long rivers, and wide river basin, having aquaculture, forest, crop field, and cities, coastal regions, and island regions, to be able to cover a variety of climate, weather, environments, culture, and economies. In 2019, we have collected many products listed here from Australia, China, Japan, and Korea. However, honestly speaking, the function to use these products were not working well. So we felt it is necessary to improve. We have been discussing more among co-chairs of Coordination Board of AOGEO and moving to change this system to the right hand. We are now testing Open Data Cube in each countries of co-chairs to be able to provide each products from each system. More challenge will be needed to develop networks among each system in the next several months. Our one of co-chairs of Coordination Board, Dr. Yonseo Kim from Korea, will report this progress tomorrow. Next slide, please. As I mentioned earlier, recently we have started capacity development in AOGEO regions. Last year we had the third workshop in hybrid style at Changzhou in China and also online. Training courses were taking place for 2 weeks by the leadership of Professor Xian Zhou. During the training courses, Geoscience Australia shared the Open Data Cube technology to all participants. And honestly, and also my capacity, I'm also one of the training courses, and my capacity was also developed to use the Open Data Cube. In more details, we will discuss capacity development in a special session 2 tomorrow. Finally, I introduce Newborn Challenge from the Pacific Islands. It was originated from the Canberra Declaration in 2019, in which we say, welcome new members from Pacific and other island nations to the GEO community and recognize the significant capabilities they have to offer, and emphasize the importance of GEO being inclusive of these countries with their significant and increasing exposures to the disaster risk, climate change, and sustainable development challenges. Following the Canberra Declaration, GEO developed the Pacific Island Advisory Group during the terms of 2020 to 2022. In session 3, we will discuss more about potential in collaboration between AOGEO and PIAG. So next please. I will summarize my talk as scene setting. The title of symposium is Enhancing the Well-being of People in the Asia-Oceania region through Earth observation in the face of COVID-19 impact. Design and implement future steps for Earth observation to realize global agendas. International policy linked to the geo-engagement priorities. The system is organized as this. In the first day, we will have several country reports after my talk and have a special session 1 focusing on SDGs. Session will be mainly conducted by EO4 SDGs, focusing on the AO regions. In the second day, we will have chance to hear progress by each task groups and also IPS. After reporting session, capacity development and knowledge sharing session will be conducted. In the final day, focusing on Pacific Island, we will discuss potential collaboration between PIAG and AOGEO. Since the Bolero winter 2020, we have been facing difficult time due to COVID-19, and we have had many challenges issues. This symposium is also one of our challenges, how we will move forward necessary discussions in AOGEO and also GEO. So after session 3, we will have wrap-up session focusing on the impacts from COVID-19 and on overcoming COVID-19, and then to produce innovation. Finally, we will adopt a statement and bring this symposium to a close. I just want to pay your attention. Symposium will be conducted for 3 days. Considering the time differences, we will have 3 hours, 30 minutes sessions every day. On the day 3rd, starting time is set to be earlier for the participants from the Pacific Islands. So next, please, thank you again for joining this symposium. I hope that you all enjoy all talks in the next 3 days. Thank you very much.
Thank you very much. Thank you very much, Ando-san. Thank you very much for a very comprehensive introduction. So let us move on to the country report session. We had a video recorded report from 11 countries. We appreciate your input. So first report will be presented by Dr. David Hudson. He's a Senior Advisor of Observation of Geoscience Australia.
Hello, my name is Dr. David Hudson, and I am the Asia-Oceania Geo co-chair from Australia. Here in Australia, it's been a very big year for our contributions to AOGEO, and it's my pleasure to present the Australia Country Report for the last 12 months. It's been a very big year in Australia for Earth observation, with our domestic program kicking into high gear, rolling out our Digital Earth Australia program, and also ramping up our regional SouthPan program for GPS augmentation. More regionally, we've been working in Africa on the Digital Earth Africa program, where our priorities are moving towards ongoing sustainment of that program and embedding it into Africa, rolling out the next generation of Earth observation products similar to the Digital Earth Australia program. In the Pacific, we've also seen the establishment by GEO of the Pacific Island Advisory Group, or PAG, and that's a fantastic initiative following on from the recommendations of the GEO Ministerial in letting the Pacific figure out its own destiny and figure out its own requirements for Earth observation. Within AOGEO, we've also been pushing forward with data sharing, scientific exchange, and the integrated priority studies. These activities have been really successful, where we've seen new data following the GEO Ministerial in Canberra in 2019 starting to flow through the Earth observation system and be used for a whole variety of applications. So really looking forward to the rest of the symposium, and thank you again for the opportunity to address you.
Thank you, David, for the very nice presentation report from very nice location, very sunny forestry. So next report will be presented by Mr. Ahmed Samsadin. He's the Director of Bangladesh Meteorological Department.
Bangladesh is one of the most disaster-prone countries in the world due to its geographical context. Bangladesh Meteorological Department is the only mandated organization of the government to monitor local observation system, the meteorological and seismological activities nationwide. As part of the Earth Observations BMD for weather parameters data has 47 first-class observatories, 49 automatic weather stations as synoptic observations, 10 pilot balloon and drawing-sound observations as upper air observations, radar observations, satellite imagery, Himawari coast, along with 10 seismic observatories to analysis, prepare and disseminate daily and different time scale weather forecasts and issue weather signals during the disaster like tropical cyclone, heavy rainfall, thunderstorm, etc. for safety movements of the people and for taking early preparation by the stakeholders to reduce the loss of lives and properties, consequently contributing national economy. BMD is striving to enhance the Earth observation categories for government decision makers and users, working together with national and international bodies like Asia Oceania GEO to keep pace with the other nations. BMD is on the roadmap to implement the different Earth observations parameters with the existing system to prepare weather forecasts. BMD has launched agrometeorological advisories for the agricultural resources and for the farmers at the root level, soil moisture network, system has been installed to monitor drought, and carbon monitoring system has been systemized. Real-time rain monitoring online system have also been installed and commissioning, and the relevant data are kept open for all. To know the surface conditions of the oceans, few buoys established has been completed at the coast region of Bangladesh. After all, in consideration of the national economy and sustainable development of the country, being an active member of GEO and AOGEO Bangladesh, that is BMD, in the coming days, we'll focus increasing the number of observations and adopt digital strategy for accurate, effective, and time manner weather forecast. Last of all, I hope the new and scientific approach of AOGEO will play an important role, contributing the global Earth observation management system, data sharing, and capacity building to build the Asia Oceania region more resilient.
Thank you very much. I'm very glad to hear that Himawari satellite is contributing to Bangladesh as well. So next report will be presented by Dr. Wang Jian, Director of GEO China Secretariat and Director General of National Remote Sensing Center of China, MOST.
Distinguished Mr. Horiuchi, dear colleagues and friends in Asia and Oceania, warm greetings from Beijing. My name is Wang Qian, Director of GEO China Secretariat and representative of GEO co-chair Dr. Huang Wei. I'd like to thank Mr. Horiuchi for inviting me to share with you the latest achievements of China GEO here. If there were not COVID-19, we should be sitting together face-to-face today. Anyway, we should give our sincere gratitude to MAXT of Japan and the GEO Secretariat for their great efforts to prepare this symposium. Nowadays, the international society is still in a tough battle with the pandemic. As you know, Earth observations and geospatial big data have been such a great help for public services and government decision-making. In the past year, high-resolution satellite images and nighttime light data were applied to compare and monitor the activities in several urban regions before and after COVID-19. We found the changes could be obvious, which means the pandemic has significantly influenced our day-to-day life and industry production in the short term. But the good news is, through Crop Watch system, we were very happy to learn that the pandemic had very limited impacts on crop production and food security in China throughout 2020. Meanwhile, China GEO has also been doing many works on climate change, disaster risk reduction, and sustainable development. Last September, China made the latest global Land 30 dataset open access to the world, which covers an area of 149 million square kilometers with over 85% accuracy. The dataset can be used as a base for monitoring global change and the realizing of sustainable development goals. To further support climate change research, China GEO also evaluated the Antarctic ice shelves calving, which has been included in the GEO 2020 highlights report. With regard to disaster risk reduction, China GEO has provided data services for those countries suffering disaster emergencies through disaster data response mechanisms, such as SADOP reservoir dam collapse in Uzbekistan in 2020. How it works has been released in UN ESCAP's publication. All those works you can find on the related websites. For a long time, AOGEO has played an important role for Earth observations, technology, application, and capacity building in this region. Many AOGEO members have made great efforts to organizing various activities. China also would like to do our best as well. As you know, last October, the third AOGEO workshop and the international training workshop was successfully held, in which I suppose many of you attend online as well. In the future, as one of the GEO co-chairs, China will continue to fully support activities in AOGEO with all our friend countries. We also hope that more and more countries and international organizations could actively join us to promote the development and utilization of Earth observations and bring benefits to the people in Asia-Oceania region, even all over the world. Thank you very much.
Thank you very much, Dr. Wang. I'm sure we will recover from COVID-19 pandemic, and I'm sure China will play a great role. And next presentation will be from India. Let me invite Dr. Shri Ubamaheshwarawan. He's Scientific Secretary of Indian Space Research Organization.
Hi, greetings from ISRO to all distinguished delegates and participants. It is interesting to note that AOGEO touches upon the important theme, role of Earth observations for enhancing the well-being of people in the Asia-Oceania region, especially in the aftermath of pandemic. In India, ISRO has taken special interest in studying these impacts of reduction in industrial activities and vehicular traffic during lockdown using space and in situ data, and in fact, it has provided some interesting observations, which I will explain in brief. As an example, the NO2 tropospheric column measured from satellite sensor during 2017 and to 2020 showed that there was a significant decrease in spatial distribution of NO2 due to the reduction in the anthropogenic activities. If you take another example, it is on air pollution monitoring, where satellite-based observations showed a decrease of about 20 to 36% in aerosol optical depth levels across the country and a decrease of about 40 to 50% in particulate matter PM 2.5. Now, if you take the water pollution studies, satellite images clearly showed reduced turbidity levels in the river Ganga due to reduction of outflow of industrial waste. In India, ISRO offered geospatial technological solutions to various central and state government departments through Indian geoportal Bhuvan. ISRO brought various mobile applications and web-based utilities which helped in identifying the location of COVID cases, geotagging of home quarantined patients. I would like to make a special mention about the role played by satellite images in studying the recent flash flood occurred in Himalayan state on February 7, 2021. Large amount of satellite data has been provided by various countries under the International Disaster Charter, Sentinel Asia and UN ESCAP mechanism. Now, coming to the recent additions of space assets of India in Earth observation satellites, India has launched 3 advanced remote sensing satellites, Cartosat-3, microwave imaging satellite RISAT-2BR1 and EOS-1. In conclusion, I would like to thank AOGEO organizing team for this opportunity, and I wish all these efforts would definitely benefit of global community. Thank you.
Thank you very much. I like that the model of rocket launcher with him, Indeed, India has a very nice launchers. So next, from host country, Japan, let me invite Mr. Horiuchi Yoshinori, Deputy Director General, Research and Development Bureau, Ministry of Education, Culture, Sports, Science and Technology.
Hello, I'm Horiuchi Yoshinori, Geo Principal of Japan. Earth observation data is critical in addressing global agendas. Japan has continued its efforts in contributing to global agendas using Earth observation, such as through the following 5 examples in the AO region. The first is Earth observing dashboard on COVID-19. JAXA with ESA and NASA developed the dashboard last June and continued to enrich the content by sharing its satellite data and analysis results on environmental and economic effect of the pandemic. For example, you can see the changes of CO2 density over large urban areas as illustrated by the analysis of the Japanese satellite observations for the first few months of the COVID-19 breakout compared to the corresponding pre-pandemic period. The second is GS map for monitoring and managing disasters, agriculture, energy, and water resources. JAXA provides this highly accurate, high-resolution, and real-time global rainfall map on its website for free. GS map has been widely used in AO countries, including Pacific Islands, for rainfall monitoring, flood prediction, and drought monitoring, which are even more important in the COVID-19 era. The third is JJ-FAST, a web-based system to monitor tropical forests, operated by JICA and JAXA since November 2016. Using JAXA's AROS-2 data, JJ-FAST releases deforestation data every month and a half, including in the rainy season. Users can easily access it from PCs and mobile devices and download that data. The fourth is AP-PLAT, launched in June 2019 to support climate change adaptation measures in the AO region. The website has been developed to provide scientific knowledge and use for regional adaptation strategies for climate change. The last example is DIAS, which is an information platform to achieve, integrate, and analyze big data of Earth observations and predictions, operationally used in Asia and Africa. Currently under development in the Philippines, specifically in Davao City, is a system with real-time flood forecasting and warning services which has already been available for the Pampanga River Basin, in addition to e-learning and climate change impact assessment abilities. As Japan continues these activities during and beyond the COVID-19 era, active cooperation, including online information sharing, is much appreciated. We look forward in continuing collaboration in AOGEO. Thank you.
Thank you very much. I'm personally honored to be a member of Japan GEO and supporting these activities. So let us move on to next report from Korea. Let me invite Mr. Chang Yun-lee. He's Director General, Space and Nuclear Energy Bureau, Ministry of Science and ICT.
Ladies and gentlemen, we entered the year of 2021 with a strong hope for return to normal life through COVID-19 vaccination and economic recovery. However, the shape of the recovery is likely to be uneven, uncertain, and unequal, and this poses even greater challenges to our global agenda. With fewer than 10 years left before we reach 2030, the world needs urgent collective action to achieve the Sustainable Development Goals. The contributions of AOGEO community will be essential if we are to succeed. In this light, I would like to make the following 2 points. First, Korea is working hard to achieve the SDGs adopted in 2015 because the SDGs promote the shared vision and long-term approach required to address global challenges. In this regard, Korea established the comprehensive plan for utilizing satellite information in 2019. It contains a policy direction to help satellite data contribute to sustainable development as well as quality of life. Last year, Korea launched the second generation geostationary satellite. Its mission is to observe the marine and atmospheric environment covering the Korean Peninsula as well as neighboring East Asian region. It can contribute to monitoring the marine environment and pollution in the region. Secondly, climate change cannot be solved only by the effort of individual countries. Korea believes that the spirit of AOGEO, which continuously monitors climate change based on sharing and integration of observational data, is very important, particularly Asia, Oceania, home to more than half of the world population, has a high risk of disaster caused by rapid climate change. In October 2017, Korea proposed a pilot study at the AOGEO Joint General Meeting in Washington, D.C. The idea was to select areas of high value for joint research in Asia Oceania and support available Earth observation data for that. This was realized in the concept of integrated priority studies, reported to the 44th AOGEO Executive Committee in July 2018 after discussion by the AOGEO Program Board subgroup, and approved as the AOGEO Work Program 2020 to 2022 at the 16th AOGEO Plenary in November 2019. Unfortunately, this project was not smoothly operated last year due to the sudden pandemic. The Korean government will actively support the IPS project with observation satellites. In conclusion, as a member of the AOGEO, Korea will continue to make efforts to solve the social and environmental issues and contribute to the sustainable development for our region. Thank you.
Thank you very much, Mr. Lee. Congratulations on your successful launch of the satellite last year. I'm sure the satellite will acquire very important data. So next, I'd like to invite Mongolia, Dr. Sevjit Enkutbutsin, Director General, National Agency for Meteorology and Environment Monitoring of Mongolia.
Dear Dr. Gilberto Camara, AOGEO Secretariat Director, and dear participants of the 13th AOGEO Symposium, Mongolia became a member of the AOGEO by resolution of Government of Mongolia in 2016. The Mongolian AOGEO national team consists of experts from 12 organizations, including ministries and agencies responsible for the 2030 Agenda for Sustainable Development. AOGEO membership of Mongolia will strengthen not only bilateral and multilateral cooperation activities with other AOGEO member countries and organizations, but also strengthen cooperation among different governmental organizations within Mongolia. Understanding of the Earth system, its weather, climate, oceans, atmosphere, water, land, natural resources, ecosystems, natural and caused by human activities, disasters, are the most important factors for strengthening human health, security and property integrity, global environmental protection, disaster risk reduction, and in the process of achieving sustainable development. Mongolia is interested in cooperation in many fields that AOGEO focuses and mainly in the area climate change, drought and desertification, land degradation, water resource management, natural disaster risk management, biodiversity and ecosystems, environmental monitoring, agriculture, etc. In the National Network of Hydrometeorological and Environmental Monitoring, 318 meteorological stations and posts, 4 upper air stations, 9 dust storm stations, 36 air quality monitoring stations, 2 satellite data receiving stations, 1 meteorological Doppler radar station, 160 hydrological monitoring posts, and 1 acid deposition station are being operated. Beside this, water quality control is carried out at 184 points and soil quality control at 400 points. Using data from the National Network of Hydrometeorological and Environmental Monitoring, the National Agency for Meteorology and Environmental Monitoring of Mongolia provides services to businesses, governmental organizations, and citizens with short, medium, and long-range weather forecasts, dust storm forecast, drought and drought risk maps, forest and steppe fire maps, air quality data, information for rivers and lakes water level, runoff, ice depth, and ice phenomena, water and soil quality data. All these data are regularly reported on the website Sagar.mn, which contributes to reducing the risk of national and weather disasters. In the future, it is necessary to improve the quality of the above information and data, extend the national network of hydrometeorological and environmental monitoring, automate instruments and equipment, expand the meteorological radar network, improve capacity building, upgrade supercomputer, and improve the effectiveness of numerical weather prediction model. I wish every success to the 13th AOGEO Symposium. Thank you.
Thank you very much. Thank you for a very comprehensive report. I'm sure Mongolia will play an important role in Earth observation. So let us move on to next country, which is Thailand. I'd like to invite Mr. Tatya Chuntoragun. He's Deputy Director, Geoinformatics and Space Technology Development Agency.
Good morning, good afternoon, good evening to all participants. On behalf of Thailand and GISTA, it is my honor to share you all about applications related to Earth observation and geoinformatics that are in focus for well-being of our Thai people. Due to time limitation, only 3 demonstrations on agriculture and urban and social security applications are chosen to share with you. These applications have been considered having impacts to social and communities and in focus presently. AOGEO 4.0 is a policy level for overall agriculture management for Thailand. The urban and social security topic, I'll show the respiratory health and air pollution project and a little touch on COVID-19 IMAP, focusing on managing economic crops for the whole country in order that all stakeholders would be able to monitor status and health, predict yield and harvesting date. AOGEO 4.0 is the application that provides those aspects of information. Rice, maize, cassava, and sugarcane information are provided on weekly and fortnightly basis, while power rubber trees and oil palm trees are on yield basis. It provides information for management in country scale and individual farm scale management with capability of digitizing farm plots, farm scale related data, input and analysis. The information is used by many ministries to efficiently manage the value chain of agriculture goods for both production sector and marketing sector. Next, the applications for health related issues. Applying EO data from MODIS and Himawari 8, GISTA with partners have developed the geospatial platform to provide PM 2.5 information for public and government agencies, consolidating various associated data from satellite ground sensors and related factors, not only surfacing hourly information, but also forecasting PM 2.5 intensity for upcoming hours will be ready for services in next few months. The information intends to serve Thai citizens for self-preparation for outdoor activities and their livings. Our further activities will expand to more collaboration with universities, NIER from Korea, UNESCAP, National Astronomical Research Institute of Thailand, and many other entities. Lastly, COVID-19 IMAP is a GIS platform used for integrating data from more than 15 agencies and 9 ministries, which are determined as necessary for COVID-19 administration. Instead of accessing many websites to seek for data and information, only selective data are analyzed, summarized, and displayed in the form of maps and dashboard in user-friendly manner. This aims to prevent and reduce risk of disease spreading, determining impacts of measures that implemented, and effective resource management. Thank you for your attention.
Thank you very much. Thank you for a very impressive presentation. Their activities is very wide and a variety. So next, I'd like to invite Vietnam, Dr. Vu Antoine. He's Vice Director General, Vietnam National Space Center.
Hello everyone, my name is Vu Antoine. I'm Vice Director General of Vietnam National Space Center. I'm very pleased to give you some information about the situation of Vietnam as a country report for the 13th Asia-Oceania Group on Earth observation. As a first, I would like to update you some important information related to the Earth observation in Vietnam during last 2 years. There are 2 new national strategies has been approved. The Strategy for Development and Application of Space Science and Technology to 2030 and the Strategy of National Remote Sensing Development to 2030, Vision to 2040. The 2 strategies will help Vietnam focus its resources in applying the Earth observation to environmental management, natural disaster prevention towards sustainable development, and response to climate change. However, it does not mean that everything will suddenly happen this year. Since 2018, Vietnam has built a Vietnam Data Cube system based on the foundation of the Open Data Cube. So far, Vietnam Data Cube system has 3 applications on national scale: forest monitoring, rice monitoring, and water surface monitoring. As the year 2020, Vietnam faces 2 historic floods with huge damage in central region of Vietnam. Within 2 months, from October to December, 7 typhoons hit the central region, causing serious flood and landslides. The use of the Earth observation data in this situation has given Vietnam many valuable lessons, in which the most important is the assurance of availability of data and suitable technology to provide timely information to the disaster-affected area. Vietnam Earth observation data is currently provided by the VNRESat-1 satellite and optical satellites. Vietnam is expecting for second small satellite, Letosat-1, will be on orbit from the end of 2023. However, in the case of the emergency, the Earth observation data of Vietnam does not meet the requirements. The lessons from Vietnam point out that any help in case of emergency is valuable. Accordingly, Vietnam would like to contribute and also to expect AOGEO, the satellite data, especially SAR data, in case of emergency, as well as the technical and experience exchange in Earth observation applications. I hope my presentation brings some information to you.
Thank you very much, Dr. Tuan. I'm very excited about development of your satellite, Letosat-1. So next, the report from Cambodia. I'd like to invite Dr. Meng Kim Ho, Deputy Director General, National Institute of Statistics, Ministry of Planning.
Great honor for me. On behalf of the Cambodia GO principal, I would like to share my presentation on the Cambodia GO activity for participate the 13th AOGEO Symposium as the follow. The main content is the background, Cambodia GO logo, vision and mission, Cambodia GO structure, Cambodia GO activity, challenges and conclusion. So the slide will show detail as the follow. Thank you.
Thank you very much, Cambodia. Thank you for a very quick report. This video will be on the website later, so the participants can watch the video or the report again later. So finally, it might not be on agenda yet, but we have received a report from Indonesia in the last minutes. So the last report will be presented by Lapan.
Remote sensing is a key on the Earth observation activities. Referring to Indonesian Space Act and the government regulation on remote sensing, there are two main roles of LAPAN on remote sensing. First role is to provide remote sensing data for whole Indonesia. And second is to provide the methodology to process remote sensing data to become an information such as land use or cover, change detection, natural resources monitoring, etc. Based on those roles, LAPAN developed 3 ground stations to receive remote sensing data. Those are located in Bogor, Jakarta, and Parepare. The ground stations receive low, medium, high, and very high spatial resolution imagery. For medium resolution, LAPAN could provide free mosaics data for whole Indonesia every year. For the applications, Indonesia applied remote sensing data for natural resource monitoring, environment, disaster, and also other strategies such as security and defense, law enforcement, and illegal activity monitoring. We actively do disaster response in Indonesia. Remote sensing data is useful to detect the affected or damaged area. Related to the Sustainable Development Goals, or SDGs, Indonesian remote sensing activities support the SDGs 02, Zero Hunger, SDGs 06, Clean Water and Sanitation, SDGs 11, Sustainable Cities and Communities, SDGs 13, Climate Action, SDGs 14, Life Below Water, and SDGs 15, Life on Land. In the pandemic period, remote sensing in Indonesia also support the COVID-19 monitoring. We developed LAPAN COVID Hub to show where is the risk area for COVID-19 diseases. To strengthen the capacity, national and international efforts have been conducted by LAPAN with several partners such as ministries, institutions, universities, private companies, and local governments for national collaborations, and with NGOs and other space agencies for international collaborations.
Thank you very much, Lapan. It's a very nice and sophisticated presentation. So this is all we have. Thank you very much for watching, and I appreciate the report from member countries. So we have a lot of time, but now we have almost a 50 minutes break until 5 p.m. in Japan time. It's quite a long break, but during the break, we will play some videos introducing the Earth observation activities of host country. So I hope you will relax and enjoy the videos. And before videos, no, after the break, special session 1 will follow. So we will discuss linkage between Earth observation and the statistical community for SDGs. That session will start 5 p.m. in Japan time. So please make sure the restart time in your time zone and come back. And before the break, we have another video message from Mr. Kaname Ikeda, President of ResTech. So I hope you enjoy the videos and see you again in 50 minutes.
Ladies and gentlemen, good afternoon. I am Kaname Ikeda, President of ResTech, Remote Sensing Technology Center of Japan. I am delighted to have this opportunity to greet you at the opening of AOGEO Symposium. First of all, on behalf of ResTech and on my behalf, I have to thank the GEO Secretariat for giving us a mandate to organize AOGEO Symposium again this year. Today, needless to say, we have two major global issues worldwide. One is climate change, and another is latest one, COVID-19 pandemic. As a matter of fact, we have been engaged in preparation of this symposium in a conference hall in Japan, as it was in the past. Therefore, it is a little regrettable that we are obliged to hold this symposium as a video conference due to unforeseen circumstances of COVID-19 pandemic. However, we are happy about this new attempt to organize the virtual conference as an opportunity where all the concerned countries and organizations could get together. I understand that AOGEO Symposium could be organized biannually here in Japan. Therefore, I do look forward to seeing you all actually here in Japan in 2 years. By that time, I do believe this pandemic could be over and our lives are back to normal. During break time after this, you are invited to look at introduction of research projects conducted by the Ministry of Education, Culture, Sports, Science and Technology, MEXT, and other Japanese institutes. I wish you enjoy it. Please stay and join the online AOGEO Symposium. Thank you very much for your attention.
This movie explains DS, Data Integration and Analysis System, as a major contribution to GEO from Japan. DS is not a simple computing system. DS is an integrated scheme, consists of IT infrastructure, includes the super high-speed internet for academia, SINET 5, an extra-large data storage, data management system, IT researchers and various research communities, includes climate, water, disaster, agriculture, biodiversity, public health and so on. Here is a success story using DS in Sri Lanka. The devastating flood disaster occurred in Sri Lanka in late May 2017, leaving over 300 people dead and missing. Since further flood damage is anticipated, University of Tokyo and NICHAM developed to provide real-time flood forecasting and monitoring system on DS. The system integrates ground and satellite precipitation data, rainfall forecasting data, results of flood inundation analysis and forecasting. The information provided in real-time basis to the related organizations of the Sri Lankan government. This is another story in Brazil. DIAS contributes to develop agriculture drought monitoring and prediction system. Responding to a request from the World Bank Group, in March 2019, ICHAM and UTOKYO demonstrated a state-scale system using the coupled land and vegetation data assimilation system for agricultural drought monitoring on DIAS, putting a high valuation on its performance. The Secretariat of Agricultural Development of Ceará decided to provide the DIAS with local farming information obtained through the network of state agricultural instructors in real time. In Southern Africa, the establishment of an early warning system for malaria incorporating climate prediction using DIAS is ongoing. By using DIAS, the information system demonstrates with following functions. Function 1, DIAS receives malaria case data and climate data. Function 2, the data are incorporated into the prediction model. Function 3, predict malaria outbreaks operating the model on DIAS. Function 4, deliver the outbreak forecasting information to the community. Based on the prediction, the local government increased stockpiles of drugs and carried out extra vector control in the hotspot areas. For the dissemination of the prediction, applications for smartphones and tablets are developed by DIAS IT researchers. On 20th of May, 2019, DIAS made a press release about starting the development of super high precise prediction only using theory of mechanics with considering all urban infrastructure data. It is called as SUIPUS, Seikinase Urban Inundation Prediction System. The first version of the system is now in development for central Tokyo using precipitation radar, X-rain and JM-MAIS rainfall forecast on DIAS. As a theory, SUIPUS was established by Professor Seikane already. However, it was a big challenge for the system how shorten the computing time for the prediction. Through the collaboration with DIAS IT researchers, the computing time was dramatically reduced. Now, the system can deliver the prediction with 30 minutes ahead. DIAS continue to develop applications can contribute Sendai Framework, Paris Agreement and Sustainable Development Goals. DIAS continue to collect and deliver the Earth observation data to the societal needs. DIAS continue to collect all metadata of Earth observations registered in the implementation plan of Japan and connect with GEOS. And now, we are preparing to start DIAS for commercial use. The third period of DIAS project will continue by March 2021. The planning for the next phase is ongoing by the Government of Japan. For further information, please contact a DIAS office, managed by Remote Sensing Technology Center of Japan, RISTEC.
Human beings are facing global challenges, the Sustainable Development Goals. Japanese Space Agency, JAXA, has now initiated the contribution from space. JAXA for SDGs.
JAXA is Japanese Aerospace Agency, and it is our mission to address global agenda by science and technological innovation. Through R&D activities in the field of aerospace, JAXA especially contributes to science and technological innovation for the UN Sustainable Development Goals. We take SDGs as an opportunity to expand innovation through partnerships with various stakeholders and to create new societal values. We believe such technological breakthrough facilitates realization of safe and secure society with no one left behind. With this regard, JAXA has been implementing various programs which contribute to the achievement of SDGs. For example, we provide satellite-based information for addressing diverse global challenges, including natural disaster and climate change, and capacity building utilizing Japanese experimental module Kibo. To achieve SDGs, we need credible and objective evidence that shows what's happening on the Earth and how we are addressing it. JAXA believes satellites are the powerful means for SDGs. space is a unique vantage point to observe the entire Earth. From space, satellites unveil the situation of the land, ocean, water, atmosphere, and human activities in a global scale. I believe these evidences from satellites will guide us to make better decisions and take appropriate actions for achieving SDGs. JAXA is ready to support SDGs through our satellites and missions with our global partners. Let's take an action together. Space is the enabler of SDGs.
JAXA's Earth observation satellites contribute to a wide variety of fields effectively, such as addressing climate change, disaster response, agricultural forestry and fisheries, and also for the Sustainable Development Goals. From 2008 to 2012, 144 million people lost their homes because of disasters. The radar satellite ALOS-2 acquires various data of the land. Comparison of satellite data of before and after disasters makes it possible to grasp damage situation of wide-spreading floods. The satellite data of rainfall observation is also utilized for flood projection. According to WHO's report, air pollution kills approximately 7 million people a year, and 90% of the global population are living in polluted air. Japanese satellites Himawari and GCOM-C are monitoring the air pollutants and contributing to predict its concentration. According to FAO's report, hunger has been on the rise over the past years. In 2017, 821 million people, 1 out of every 9 people, were suffering from hunger. In this situation, it is important to understand the food production status. The data from JAXA's Earth observation satellite is expected to contribute to each country's agricultural policy making, including agricultural statistics and production planning.
JICA is Japan's development aid agency. Our mission is to support SDGs through international cooperation. Sustainable forest management, which is by itself SDG 15, is one of key climate mitigation measures for SDG 13. Our counterparts in this cooperation are countries with vast tropical forests such as the Amazon, Congo Basin, and tropical Asia. These forests play crucial roles in combating climate change both locally and globally. JAXA is supporting JICA's counterparts in enhancing their capacities to monitor vast forest land through its Earth observation technologies. During the rainy season, optical satellites have difficulties to monitor tropical forest due to the thick cloud cover. JAXA's ALOS-2 provides a state-of-the-art solution. It is equipped with radars that can penetrate clouds. Thanks to the data provided by ALOS-2, our counterpart countries can deter unsustainable deforestation in their jurisdictions. As a development aid agency, JICA wishes to embark on dialogues with our partners on how to diminish incentives for unsustainable deforestation. These together are expected to pave the way to improve our partner countries' policy frameworks and law enforcement. JICA will continue to aspire for the achievement of SDGs in partnership with JAXA.
What is now happening on the Earth? Our Earth observation satellites provide the information from space. JAXA aims for satellite observation data to support better decision-making and appropriate actions. JAXA for SDGs.
At this very moment, deforestation is occurring worldwide. Japanese astronaut Soichi Noguchi talks about the importance of protecting the global environment.
The Earth, as we see from the International Space Station, is very beautiful. All the astronauts who are flying in space always say there's no border on Earth. Earth is definitely borderless, which means whatever the change happens in one part of the world will expand to the rest of the world. So we have to know what's going on this Mother Earth, and we have to react to it promptly.
We want to protect our precious forests. A project using the Japanese Advanced Land Observing Satellite ALOS-2 swung into action. It's the JICA-JAXA Forest Early Warning System in the Tropics, or JJ-FAST. Professor Masanobu Shimada, a member of the ALOS-2 development team, is now involved in the analysis of JJ-FAST data.
熱帯林に行きますと1000回撮って7回しか晴れた画像が撮れないぐらいに曇ってる画像が多いんです。JJ ファーストっていうのはレーダーを使ってますもんですから曇ってても多少雨が降っててもちゃんと画像が撮れますよっていうのがとてもいい点なんです。
The ALOS-2 observes the Earth's surface from an altitude of 630 kilometers using radar. Changes in the tropical forests are updated on an average of once every 45 days. The locations where deforestation appears to have occurred are indicated with colored pins. When a pin is clicked, information on that location is displayed, including the latitude, longitude, and area. In this way, the detailed condition of the places where JJ-FAST has detected deforestation can be perceived immediately. Today, JJ-FAST is monitoring forest changes in 77 countries. Since it was launched in November 2016, it has detected 17,000 cases of deforestation.
JJ-FAST, qui va nous aider à assurer une surveillance constante. Pour nous, c'est une aubaine, c'est une grande opportunité que nous devons vraiment saisir pour améliorer notre façon de gérer les forêts et atteindre nos objectifs quant à ce qui concerne la gestion durable de nos forêts, l'atténuation des émissions de gaz à effet de serre.
It takes a very long time for a forest to mature. Forests can change the world. Satellite technologies and global partnerships can contribute to forest conservation, which is the foundation of people's lives and sustainable development. Forest conservation efforts to address the challenge of climate change through the improvement of forest governance using Japanese satellite technology will continue.
Rapid decrease in Arctic snow and ice and significant environmental changes are the most drastic evidence of global warming. Better understanding of the status and trend and causes of Arctic environmental changes and accurate future prediction are very important, not only for Arctic but also global climate issues. JAMSTEC have been conducting the Arctic research since early 1990s. Then, with accumulating our experience for the Arctic research and also in the context of growing social interest of Arctic issues, JAMSTEC established the Institute of Arctic Climate and Environmental Research, so-called IACE, on April 1st, 2015. We are now investigating Arctic environmental changes using research vessel Mirai, Earth simulator, and other facilities. Research vessel Mirai has been conducting the Arctic Ocean observation cruise almost every year since 1998. Our research target is mainly in sea ice reduction area to understand what kind of changes and impacts can be found after sea ice retreat in the Arctic. We found that due to global warming and sea ice reduction, the Arctic Ocean is warming, freshening, and changing more active. Also, it was a very cold and quiet ocean with sea ice cover. We also understand that, especially in the Pacific sector of the Arctic Ocean, influence of Pacific water inflow through the Bering Strait are very important from not only physical and chemical, but also biological points of view.
To evaluate the impact of the Arctic environmental stressors on marine organisms and ecosystems in lower trophic level, we have conducted field observation, plankton culture experiment, and development of numerical modeling. Ocean acidification is proceeding in the Arctic with the fastest rate of the world due to sea ice reduction and increase in freshwater input. Micro X-ray computer tomography technique is one of the useful methods for ocean acidification research. Using this technique and collected samples from the Arctic Ocean, we can evaluate the change of carbonate shell density of plankton foraminifera and theropod dwelling under the condition of ongoing ocean acidification. In this research unit, we also started collaboration with ocean policy experts for further research on marine ecosystems and educational outreach activities.
Temperatures have been increasing at higher rate in the northern high latitudes, especially over the land area. This can greatly alter the atmosphere and the terrestrial surface environment, such as permafrost degradation, wildfire, and greenhouse gas emissions from boreal forest ecosystems. We are trying to understand the impact of Arctic warming in a long-term flagship observing site in interior Alaska. The vertical, turbulent greenhouse gas fluxes between the atmosphere and the surface are measured by the eddy covariance method. We are also measuring and modeling the black carbon emission, transport, and deposition. They are also an important topic for the understanding of the role of black carbon to climate feedbacks.
Our group performed numerical experiments in order to elucidate how the Arctic and polar extrapolar interaction will be under the global climate change. Facilities such as the supercomputer, the Earth simulator, support our research activities. In our recent study, for instance, we've shown that the reproducibility of warm water transport into the Barents Sea from the North Atlantic is essential to predict the wintertime sea ice condition up to 11 months ahead in the Barents Sea and eventually in the whole Arctic Ocean.
There are lots of knowledge gaps concerning the sea ice of the Arctic Ocean, such as the sea ice thickness, sea ice dynamics, and sea ice ocean interactions. Therefore, GEOMSIC is now developing a special platform that will be moved under the sea ice and measure the various kinds of data continuously and automatically. It's like an intelligent underwater drone for the Arctic Ocean. Now, we've already designed and have started building a prototype. In the near future, we believe that underwater drones will collect invaluable data under the sea ice.
Thinking of future prediction about Arctic and global environmental changes, there are still many uncertainties. Therefore, we need to improve our understanding for reduction of such uncertainties. We need to collect accurate and comprehensive data, for instance, in the sea ice region, permafrost area, and other data in sufficient area in the Arctic. Such data and new knowledge can correct our misunderstanding of important processes for the Arctic region and support development of more accurate
climate model for future prediction. Based on our results, we continue to provide useful data and knowledge regarding Arctic environmental changes toward not only scientists but also stakeholders who are interested in Arctic and global climate issues.
Okay, let's resume the meeting. So I would like to start the special session on SDGs. Welcome back to the meeting again for AOGEO Symposium. My name is Osamu Ochiai from Japanese Space Agency called the JAXA. And then I am working for international coordination for Earth observation satellite data sets in JAXA. I am also a co-chair for GEO EO4 SDGs initiatives as one of the co-chairs. Today, we are very delightful to organize this session with my fellow co-chairs. And then this is quite exciting opportunity, meeting up with EO community with the statistic community. So this is really exciting. Thank you very much for organizing this session. Actually, this is the first time in Asia-Oceania region to organize such a session. So this is challenging and exciting. So thank you very much again for the people. And then thank you very much for audience to come to this meeting. So I would like to just explanation on the background and the objectives of the meeting. As you can see on the screen, this special session on the SDGs aimed at linking AOGEO with statistical community to help integrate Earth observation data with geospatial information and official statistics in national information system to directly support policy making. The session is designed to achieve the following three objectives, as you can see. The first one is to introduce the NSO, National Statistic Offices, to their expectation for Earth observation in supporting the SDG monitoring and reporting. The number two objective is bring together and encourage the dialogue among statistical community and Earth observation community and the use of Earth observation data for monitoring and reporting the progress of SDGs indicators. And then third one is share the knowledge, experiences, and develop good practices of Earth observation use for SDGs in AOGEO countries with support for the EO4 SDG initiative that is organized by the Group on Earth Observation. So this is general background objectives, but we have kind of a general agenda. Can you go to the agenda slides? Yes, this is just characteristic of today's agenda. We have a three presentation after introductions, and then we have a Q&A session, and then we have a panel discussion inviting three country representatives from the NSOs. And then we have a wrap-up and closing by co-chairs. So that's, general frame of this meeting today. So I'd like to hand over to my fellow co-chair, Dr. Gemma van Halderen. So, floor is yours.
Wonderful. Thank you very much, Mr. Osamu Ochiai. And it's a really great pleasure to be co-chairing this session with you today at the AOGEO Symposium. It's a real pleasure actually to be invited to be joining you in this session, and as you just said, the very first one of its kind. And for those of you who don't know who I am, my name is Gemma van Halderen. I'm the Director of the Statistics Division in the United Nations Economic and Social Commission for Asia and the Pacific, based in Bangkok. But before I joined the UN, I worked for the Australian Bureau of Statistics, so the National Statistics Office of Australia. And while I was in the Australian Statistical Office, Australia was co-chair of the expert group on the integration of statistical and geospatial information. And with my co-chair from Mexico, we worked with the expert group to strengthen the strengthen the relationship and the partnerships between the geospatial community and the statistical community. So it's a real pleasure to be here with you today, bringing the perspective of the statistical officers to the geospatial community, and in particular the group on Earth observations, who really play a very instrumental, very strong role in championing the use of Earth observations. And my very warm welcome to both my co-chair, Mr. Osama, and also to Steve Ramage from the group on Earth observations. So as we've heard, the purpose of this session, one of the purposes is to bring the National Statistical Officers' perspectives to the community, Earth observations community, and also vice versa, so that we can learn from one another. And we've chosen the SDGs and the 2030 Agenda as a common rallying point between our two communities. And so we have four national statistical officers with us today, from Japan, Mongolia, Philippines, and Malaysia, and Fiji. And I'll also bring some perspectives from the Asia Pacific region to the conversation. But it's my great honour to invite our keynote speaker, Mr. Shijiro Yoshikai, to share with us the experience from Japan. Mr. Yoshikai is the Director General for Policy Planning on Statistical Standards at the Ministry of Internal Affairs and Communications in Japan. He's been in that role since July 2020, and he oversees statistics in Japan as the head of the Coordination Office of the National Statistical System. And he also serves as Secretariat on the National Statistical Commission, on which all ministries in Japan conduct statistical surveys. He is responsible for the domestic coordination of SDG global indicators among national institutions in Japan. And he's also very active in international statistical activities, where he has a leading position of the government delegations to the United Nations Statistical Commission and other international statistical conferences. Shijiro has built a very long and established career in the MIC, which he joined in 1987, and he's held various leadership roles, including a previous post as Director General for Evidence-Based Policy Making, and so in overseeing the evaluation activities of policy proposed in the Ministry. It really is a great pleasure to welcome you here today, Mr. Shijiro, and please, the floor is yours.
Thank you, Chairs. My name is Yoshikai Shojiro. I'm currently serving as the head of the National Statistical Office of the Japanese government. First of all, I would like to express my gratitude to the co-chairs, Ms. Gemma Van Halderen and Mr. Ochiai Osamu, for giving me the opportunity to participate in this session. It is my great honor to give a presentation to experts in Earth observations. Today, I'd like to explain how Earth observations are and can be applied to SDG monitoring. Next slide, please. Let me start with a brief introduction to the fundamentals of the Sustainable Development Goals, with which all of you may already be familiar. In September 2015, countries adopted the 2030 Agenda for Sustainable Development and its 17 Sustainable Development Goals and 169 targets aiming to go further to end all forms of poverty. They call for action by all countries, poor, rich, and middle income, to promote prosperity while protecting the planet. The global indicator framework includes 231 indicators adopted by the Statistical Commission of the United Nations. Next slide, please. The advantages of Earth observations in the context of SDG monitoring were already recognized well before the 2030 Agenda for Sustainable Development was adopted, and the agenda recommends the use of Earth observations. Amid the current COVID-19 pandemic, the advantages and importance of Earth observations cannot be overstated. The Sustainable Development Goals and their targets are to be followed up and reviewed using a set of global indicators, which need to be computed by member states with an awareness of capacity development. Even though there is no room for doubt about the importance of capacity development from national statistical offices, global scale data, notably Earth observations, have advantages over country data in certain areas. Thus, they should be collected in order to monitor urgent global issues instead of waiting until the level of national statistical offices is raised. Amid concern that the stagnation of interaction within the data community due to the COVID-19 will interfere with capacity development, the advantages of global scale data stand out. Next slide, please. Next, I will explain several examples of SDG global indicators to which Earth observation methods are expected to be applied. The first one is water environment. Water scarcity affects more than 40% of people, an alarming figure that is projected to rise as temperatures do. Although 2.1 billion people have improved water sanitation since 1990, dwindling drinking water supplies are affecting every continent. There are two SDG indicators related to this issue for which Earth observation methods are expected to be utilized. Indicator 6.3.2 and Indicator 6.6.1. Indicator 6.3.2 is defined as the proportion of bodies of water in the country that have good ambient water quality. This indicator is recommended to be monitored using ground observations. The Japanese government disseminates data of this indicator. These data are obtained from water quality surveys of public water bodies, which the national and local governments are obligated to conduct based on the Water Pollution Control Law. On the other hand, Indicator 6.6.1 is currently under development. This indicator consists of several sub-indicators to monitor the change in the extent of wetlands, rivers and estuaries, lakes, aquifers, and artificial bodies of water. Satellite image data is expected to be used to monitor the spatial extent of water-related ecosystems and water quality for these sub-indicators. Next slide, please. The next global issue I'd like to discuss is urbanization. In 2007, the global urban population exceeded the global rural population, and towards the end of the 2030 agenda, the share of the world's population living in urban areas is expected to reach 60%. Sustainable development cannot be achieved without significantly transforming the way we build and manage our urban spaces. The rapid growth of cities has led to a boom in mega cities, especially in the developing world, and slums are becoming a more significant feature of urban life. The sustainability of cities is an especially relevant issue for Asia, where 7 urban agglomerations out of the top 10 are located. There are 3 SDG indicators related to this issue for which Earth observation methods are expected to be utilized. Indicator 11.3.1, Indicator 11.6.2, and Indicator 11.7.1. The government of Japan currently only disseminates data of Indicator 11.6.2. Its definition in the Japanese context is the annual mean level weighed by individual prefectural populations of fine particulate matter with a diameter of 2.5 micrometers or less, PM2.5, and suspended particulate matter, SPM, with a diameter of 10 micrometers or less, as measured by valid stations among nationwide ambient air pollution monitoring stations. We are currently implementing ground observation methods to measure this indicator. However, satellite remote sensing is also recommended by the custodian agency, the WHO. Next slide, please. The remaining indicators I'd like to mention are the ratio of land consumption rate to population growth rate and the average share of the built-up area of cities that is open space for public use for all. Both of them are currently under development. The possibility of using satellite image data is being investigated. Next slide, please. The next global issue I'd like to discuss is marine environments. Marine resources are particularly important for people living in coastal communities who represented 37% of the world population in 2010. Oceans provide livelihood, subsistence, and benefits from fisheries, tourism, and other sectors. They also help regulate the global ecosystem by absorbing heat and carbon dioxide from the atmosphere. However, oceans and coastal areas are extremely vulnerable to environmental degradation, overfishing, climate change, and pollution. The conservation and sustainable use of marine resources are central to achieving the 2030 Agenda, especially for small island states in Asia and Oceania. There are 3 SDG indicators related to this issue for which Earth observation methods are expected to be used. Indicator 14.1.1, Indicator 14.3.1, and Indicator 14.4.1. The government of Japan currently only disseminates data of Indicator 14.3.1. Average marine acidity, pH, is defined as the average value of observation-based acidity in the winter surface seawater on the 7 degree to 33 degree north latitude along the 137 degree east meridian. Hydrographic observation along the 137 degree east meridian has been conducted for over 50 years by the Japan Meteorological Agency. Next slide, please. The next indicators are Indicator 14.1.1 and Indicator 14.4.1. Indicator 14.1.1 consists of the index of coastal eutrophication and plastic debris density. The methodology employs internationally recognized methods from expert communities, including the GEO. The Ministry of the Environment and other institutions in the government of Japan are currently making efforts to compute this indicator. Indicator 14.4.1 denotes the proportion of marine fish stocks within biologically sustainable levels. The data to inform stock assessments can come from many different sources: reporting or sample-based surveys at sea, at landing sites, or within fishing communities. We are currently investigating the possibility of computing this indicator. Next slide, please. The next global issue is land environments. Plant life provides 80% of the human diet, and we rely on agriculture as an important economic resource. Forest covers 30% of the Earth's surface, providing vital habitats for millions of species and important sources for clean air and water, as well as being crucial for combating climate change. Every year, 13 million hectares of forests are lost, while the persistent degradation of dry lands has led to the desertification of 3.6 billion hectares. Wildfire and illegal logging, which crucially threaten land ecosystems, are relevant issues for Asia and Oceania. There are 3 SDG indicators related to this issue for which Earth observation methods are expected to be used. Indicator 15.1.1, Indicator 15.3.1, and Indicator 15.4.2. The government of Japan currently only disseminates data of Indicator 15.1.1. The forest area in Japan is measured based on survey on the state of forest resources. The Forestry Agency aggregates the areas of national forest based on forest registers, and so on, and compiles them together with aggregated data for private forests provided by prefectural governments. We are currently implementing survey to measure this indicator. However, remote sensing seems to be a possible alternative, according to an FAO report. Next slide, please. The next indicators are the proportion of land that is degraded over total land area and the mountain green cover index. Both of them are currently under development. The possibility of using satellite image data is being investigated. In addition, the mountain green cover index is to be computed by the Japan Aerospace Exploration Agency, JAXA. The next slide, please. Let me move on to my concluding remarks for this presentation. The internationally agreed upon SDG indicator framework consists of 231 indicators, and most of the indicators to which Earth observations are expected to be applied are included in this presentation. From the viewpoint of us Earth observation specialists, all of you, this internationally agreed upon framework might seem insufficient for monitoring the impact of the challenges we face. Aside from the framework, discussion on indicators with professional outlook will no doubt be welcomed by the data community in Asia and Oceania for the development of complementary indicators on the regional or national level. And through this process, we may be able to build a foundation for monitoring beyond 2030. That brings me to the end of my presentation. Thank you so much for your kind attention.
Thank you very much, Mr. Yoshikai. This was an excellent presentation. Really showed the extensive work that's being done there in Japan across 4 different goals of the 2030 agenda. And it was really great to see not only the examples that of where Japan is currently using Earth observations data for some of those indicators, but where you're currently exploring the use, as well as where you're also exploring methodological developments. And you also highlighted very nicely the partnerships that you as the head of the statistical system in the government of Japan, the partnerships you have with the Aerospace Science Agency, the Ministry of Environment, the Meteorological Agency, all the partners that you bring together to prepare data and compile these indicators. So thank you so much, Mr. Yoshikai, for a really excellent presentation. I'm going to build on your presentation and share a few insights from the broader Asia-Pacific region in this area of SDG progress. Before we move to our, till I move back to our co-chair and the panelists. And I'm going to present a story here about the Sustainable Development Goals in Asia Pacific. Where are we? Are we on track to 2030? And in particular, how can we leverage the power of Earth observations for the monitoring framework? Next, please. So this, as we've just heard from Mr. Yoshikai, the 2030 agenda is a very ambitious agenda. It's very challenging, 17 goals, 169 targets, and 231 indicators. And there is a lot of also demand for disaggregations. We heard in the case of Japan, maybe statistics at the prefecture level, but there's also disaggregation for gender, for cities, for disabled and other population groups. So where do we start to get a handle on this? And in Asia, here in ESCAP, we try to start with the big picture. Next, please. And we've tried and asked 2 important questions. How much progress have we made? And continuing business as usual, will we achieve our targets by 2030? So the first question is, right, where are we now? And the second question is, are we likely to be on track by 2030? Next, please. So the first question is, where are we now? And this infographic here, this illustration shows you that based on the available data from the global database that includes all countries in our region, as of now in 2020, we are not on track to achieve the 2030 Agenda SDGs. If we were on track based on the data The blue bars would be hitting that black line in the middle. The black line in the middle that's got the heading 2020 is where we should be now, based on the data, if we're on track. And you'll see from this graph that none of the goals are on track. Some of the goals are closer to the line than others, so good health and well-being, goal 3, industry, innovation and infrastructure, goal 9, partnership for the goals, goal 17. But very tellingly on this diagram is that for 2 of the goals, climate action, goal 13, and life below water, goal 14, actually the data is showing we're going the wrong direction. As of now, we're regressing, we're not progressing towards the ambitions of the 2030 agenda. The other thing I'm going to come back to in a moment is that for some of these bars, you'll see a dashed line, the bar is shaded, horizontal lines. That means we have insufficient data to really give solid evidence on these goals. Next, please. The second question is, where are we likely to be by 2030? And for this analysis, we look at the 169 targets, not the 17 goals. And this graph gives you 4 different colours. Green is that if we maintain our progress, we will reach that target. Yellow is where do we need to accelerate. Red is where do we need to reverse current trends. And grey means we cannot measure this. And again, this analysis here is can give you a lot of messages. The first one is, of the 169 targets, we're only on target to reach 11 of the 169 by 2030. For many of them, we're going backwards, but in particular, for a large proportion of them, we have no data. Data availability, the grey means we can't measure these. So it shows you where we need to not only understand what's going on, we need to measure it before we can say whether we're on target or not. Next, please. So these SDG availability is, even though it's improving, here's a graph that shows since 2017, we only had 63 indicators where we had sufficient data. Now in 2020, we have 112 on the fourth bar there, 112 indicators with sufficient data. So we are making improvements, but it's still poor. And as I said on the previous slide, 66 targets have no data. Next slide. Now, using this analysis, we can drill even further. And here, data is insufficient or missing for 80% or more of the SDG indicators, and in particular in goals 5, 11, and 14. So this graph here shows you for each of the 17 goals, where have I got sufficient data, which is the dark green, where have I got insufficient data to measure progress, that's the light green, and where have I got no data at all, which is the grey. And as we just heard from Mr. Yoshikai's presentation, goals 11 and goals 14 are very important. Life below land and sustainable communities and cities, very important. And here we have insufficient or missing data for 80% or more of those indicators in those goals and in goal 5. So it gives you an idea of prioritisation of where we can really work together to improve data availability. Next, please. Now, it's been a great pleasure over the last few years, and particularly in the last 6 months, working with the experts from the international statistical community and GGIM, the UN Global Committee of Experts on Global Geospatial Information Management, and GEO, to do some analysis of the SDG indicators which can benefit from geospatial information. And GEO, JAXA, UN GGIM, as well as ourselves here at ESCAP, have identified, have drawn on existing material from the experts who have identified 39 SDG indicators which can benefit from geospatial information. These are in goals 1, 2, I've listed them there, 1, 2, 5, 6, 9, 11, 14, and 15. And GEO have identified 29, 14 that are in common with a group called the Interagency Expert Group on SDGs and Geospatial Information, and 15 in addition. And this Interagency Expert Group has identified 24, of which there's 14 common between the two expert groups and 10 in addition. We then went looking for country examples of countries that are using Earth observations. And we were very specific here of finding country examples. So not examples of where a development partner such as myself or where an agency has produced an indicator for another country. We just looked at where a country's used the Earth observations to produce an indicator. And we found country examples for most of those goals, but we also found two country examples for two indicators that had Earth observations being used that were not on the list of these expert groups. This information I have prepared is prepared in this joint publication by ESCAP, GGIM, Secretariat, JAXA and GEO, and I was so pleased that we were able to work with GEO. And my thanks to you, Osamu, and to Steve for your support with this work. And it's available on the hyperlink there on the bottom of the slide. It's currently a work in progress. Everything you present is always a bit out of date as soon as you present it. But this was a first attempt to try and articulate this question. And so finally, my next slide, please. Using these examples, here are the SDG indicators that can benefit from Earth observation data. And we found 22 country examples from national statistical offices. And these are listed here in green. And what you'll see here is that the examples are either in green, which means they come from a statistical office, or they're in black, and they come from some other agency, such as JAXA, or such as the Chinese Academy of Sciences, or the Environment Ministry in New Zealand. It's not just the statistical offices that are using Earth observations data for the SDGs. And in Asia and the Pacific, we actually only found examples from 3 national statistics offices: the Philippines, India, and Turkey. Now the other 33 examples were from geospatial offices, science academies, academies. Now, obviously, this research here was undertaken through a desktop research. And as we've just heard from Mr. Yoshikai, Japan is only on this slide once against 9.11. And so clearly we have to make sure that we are constantly updating this to include the other presentations and other country examples from across the region and globally of the use of Earth observations. So to conclude, next please. So to conclude, this region is not on track to deliver the agenda, and data availability remains a key challenge. There's lots of opportunities, though, for monitoring the SDGs. 39 of them can benefit from geospatial information. 28 of those 39 are environment related. 3 of them, 151, 1151 and 1311, actually are identical to indicators in the Sendai framework, which I know is very important for many countries in Asia Pacific. And I know also this Sendai framework for disasters. In Asia Pacific, country examples of the use of geospatial information are scarce, and we could only find it for 7 countries. And this is why I'm really pleased to be joining this event and joining forces with GEO to highlight the examples that are possible. And it's a real pleasure to be joining with GEO to partner to make a difference in this area. Thank you very much for listening. The regional results are a tool available here on our gateway. And it's a real pleasure to provide also a couple of GIS tools. Next slide, thanks. In the interest of time, I'll conclude there. Ladies and gentlemen, that concludes my presentation, and it's a real pleasure now to introduce our next speaker, who has providing us with a pre-recorded message. Dr. AOGEO Kawada is the Program Manager for NASA's Earth Science Division's Sustainable Development Goals activities to extend the use of earth science and applications in support of the United Nations Sustainable Development Goals. She also serves as the Executive Secretary for the International Group on Earth Observations, AOGEO, Earth Observations for Sustainable Development Goals initiatives. So she actually serves on the same group as our co-chair on GEO. She holds a PhD and MS degree in Atmospheric and Ocean Science from the University of Maryland, master's degree in Applied Maths and Stats from Georgetown University, and a bachelor degree in Physics from Johns Hopkins. She's a certified change management advanced practitioner. In 2020, she received NASA's honour for excellence in innovation. Ru, would be great honour. Could you please share the pre-recorded presentation from Dr. Kavada? Thank you.
Thanks everyone. My name is Arji Kavada and I support the National Aeronautics and Space Administration's Applied Sciences program. I also serve as the Executive Secretary for the Earth Observations for Sustainable Development Goals initiative from the Group on Earth Observations. So EU4SDG is an international initiative within the Group on Earth Observations that focuses on enabling and promoting uses of Earth observation data to advance the measurement, monitoring, and achievement of the Sustainable Development Goals and their derived societal benefits. It is chaired by Japan, the US, and Mexico, and you can also see a list of some of the other contributing organizations, and I want to note that this is not an extensive list. There are many more organizations that are contributing toward our initiative. This initiative places particular emphasis on working with statistical offices and the international statistical community, in addition to other relevant stakeholders such as UN agencies, regional and international research networks, as well as other relevant stakeholders at the national, subnational, and city level, to demonstrate the benefits, help build skills, and share knowledge about how Earth observations support the monitoring and achievement of the SDGs. One of the activities that the initiative is supporting has been this SDG Geospatial Roadmap, which is led by the UN Interagency Expert Group on Sustainable Development Goals Working Group on Geospatial Information, or WGGI. And so this roadmap outlines how to build a bridge between the statistical and geospatial community working within the global indicator framework, and focuses on communicating the vision to see geospatial and location-based information recognized and accepted as official data for the SDGs and their global indicators. And so EU4SDG has offered already significant input toward the geospatial roadmap, in particular providing examples of where Earth observation data is being used to measure, monitor, and report geospatially enabled SDG indicators. And another example of an activity I want to highlight with you today is the Earth Observations Toolkit for Sustainable Cities and Human Settlements. This toolkit was launched last week at the UN Statistical Commission side event and represents an ongoing effort and collaboration between UN Habitat, EU4SDG, the Group on Earth Observations, and a suite of contributing organizations to develop a live knowledge resource to help share knowledge about how Earth observations can support and address urban-related sustainability issues. And so the toolkit provides access to a directory of over 40 representatives spanning city governments, national statistics offices, ministries, private sector, space agencies, international research networks, and EU coordinating bodies. It also aims to promote knowledge sharing and collaboration between local communities, cities, and countries. The site comprises a catalog of urban-related EU datasets, mainly ready-to-use data products and interactive Earth observation data processing tools that can be filtered by different parameters such as data type, format, source, spatial scale, temporal resolution, geographic level, or SDG indicator to help users discern application areas and distinct characteristics for the data and tools that can help address specific monitoring needs. Each dataset and tool is openly and freely available, has been peer-reviewed, and is included in the toolkit upon recommendation from Earth observation data providers and subject matter experts from the group on Earth observations. Other resources in this online resource include outreach and training materials such as videos, user guides, and webinars where available. The site also includes use cases that outline how city or national level governments and global research networks have already applied Earth observation data to fill monitoring gaps, improve the timeliness and quality of urban-related indicators, for example, looking at the average share of built-up area of cities that is open space for public use, or looking at the ratio of land consumption rate to population growth rate. The site also provides the opportunity to contribute additional such resources, so data sets, tools, use cases, training material, or other related information. And so you can do that by accessing the Contribute and Contact Us submission forms. You see the site's website at the bottom of this slide, and I invite you to visit and explore this resource yourselves. I also want to ask you to get involved, and if you have specific use cases or if you would like to contribute other input, to reach out to us and provide your feedback. In addition, we have established 4 working groups as part of this effort, and we're looking to focus on delivering impact through the use of Earth observations, developing outreach and capacity development material that are tailored toward different audiences and end users based on the technology readiness level that they may have or their capacity to use and analyze Earth observation data. And so please consider joining this effort and joining those newly formed working groups. I also want to highlight that within the EU4SDGs, the initiative's website, we have a catalog of country use cases. And so this is a total of 22 cases from 8 countries that have been collected thus far. I want to thank our former co-chair, Chu Ishida, for leading this compilation. And so as a next step, we had identified that we wanted to work more with regional initiatives, such as the Asia Oceania GEO regional initiative, to help identify and catalog more country use cases so that others can consider and learn from these use cases and consider to use Earth observation data to address similar monitoring and reporting needs. Another activity within the EU4SDG initiative has been the GeoSDG Awards program, which was launched back in 2019. And so in 2020, this was the second year of this program. And as you can see, we had a total of 14 awardees, both in sectoral and special categories. And you can see those listed here. You can go to our website and watch the recording as well as read about the awarded projects from the 2020 round. We do plan to release a call in 2021, later this spring, for the GeoSDG Awards 2021. So please keep an eye out and consider submitting a nomination. You can self-nominate or submit a nomination for another organization or project that is using Earth observations to enable the tracking, monitoring, driving progress, and planning with respect to the SDGs, to the Sustainable Development Goals. Very briefly, I want to highlight that as part of our 2020 activities, we completed the special issue at the Remote Sensing of Environment Journal. So this is another great resource that provides information on how Earth observation experts are working to help both develop methods and tailored data products that can support SDG implementation and monitoring needs, and also provide some help us provide some highlights into where there are still needs for helping connect more the data and information to really generating knowledge and helping understand partners and then apply the knowledge from Earth observations to derive insights that can help inform better management and sustainable development related decisions. And so you can see the link to that special issue. I invite you to have a look and read at those publications and editorial that are part of the special issue. I have also included a list of other resources, and so as the slides will become available to you, I invite you to have a look at those resources to find out more information. And so with that, I will close my presentation here. Please do visit our website, eu4sdg.org. And also, if you are on Twitter, follow us at EO4SDG to find out more about projects, capacity development and outreach activities that our initiative is involved with to promote the use of Earth observations for the attainment of the Sustainable Development Goals. Thank you very much.
Well, thank you very much, Dr. Cavada, and I also encourage everyone to take a look at the EO4SDG.org website. It's got a wealth of information in there of the ability to use Earth observations for SDGs, and I think this new initiative that we've just heard about partnering with UN Habitat for Goal 11, wonderful news that we've heard there. Ladies and gentlemen, we have 113 of us online with this Zoom here today, and we now have a bit of time for questions and answers, for a bit of interaction before we move to our next part. And I hand over to my co-chair to lead our panelists. You've heard three presentations, one from the government of Japan, one from the region, and also now one from Dr. Cavada from the Earth Observations for SDG of what's happening at the global level. We haven't received any questions so far from the audience. If you're not familiar with the question and answer facility in Zoom, down the bottom of your screen, hopefully in the middle of the screen, there is a Q&A icon where you can type in a question, and we as co-chairs or the panelists or the keynote speaker is able to either answer some questions now, or we will come back to you afterwards and during the next session to try and answer them. So I think in the interest of time, if there is no questions, and I don't see anybody raising their hand or to address any question, we would encourage you to have the questions in the Q&A box. I think it would be, given we're running slightly over time here, Dr. Asmu, perhaps it's time for me to hand over my duties to you and proceed with the second half of this session. So thank you very much. It was a real pleasure to be able to co-chair this event with you. And my thanks to Mr. Shijiro Yoshikai and Dr. Cavada for sharing us with those very interesting presentations. Dr. Azumu, over to you. Thank you.
Okay, thank you very much, Gemma-san, for your kind efforts to try to lead the session. Thank you very much. And then now we are moving into the panel discussion on the country cases. So what we'd like to organize this session is, firstly, we would like to introduce about the 4 country cases, including myself from Japan, at what JAXA is now doing for the indicators. And then after that, we are going to introduce about the 3 countries from Malaysia, Mongolia, and Fiji. And then afterwards, we are going to moderate the discussions. Okay, so let's just, I think before going to the details, I think I would like to ask three country representatives, Fiji, Mongolia, and then Malaysia representative, please camera on, and then so that we understand, we know your faces. So could you please turn on your camera, and then people to see. Okay, so while you are turning on the camera, I am going to my presentation firstly. So please go to the next slide. So I'm going to present about the current JAXA activities for the SDGs indicators very briefly. Please go to the next slides. Right now, what JAXA's contribution as a space agency to the SDGs indicators. You can see those list of the indicators that is currently JAXA is studying the way to utilize Earth observation data for the SDGs indicators. As you see, as Yoshikai-san has already explained, or expectation to the Earth observation. For example, 6.6.1 spatial extent of the water-related ecosystem. We have already, provide the data, our satellite data, to the UNEP as a custodian agency. That data is a global mangrove watch, a global mangrove data that was produced by the Earth observation satellite data. So that we are very much strong linkages and also engaging with the UNEP as a custodian agency, so that UNEP is now, involved officially our data for the SDGs, information, indicator information. As you can see on the right-hand side, right up side of the images, SDG 6.6.1 platform by the UNEP showing the Bangladesh mangrove data. So, so you can access the UNEP system, and so that, and then you can show, you can watch, access our data sets, and then try to capture the information for the mangrove data that was produced by the satellite data. So this is a typical kind of example, a very strong linkages engagement with the custodian agency with JAXA by using satellite data. For the other indicators such as 9.1.1 and then 11.3.1 and so on and so forth, that is still under experimental phases, how the satellite can be utilized to monitor for those indicators. So that for the time being, we would like to start case study on these indicators from the next April. And then as soon as we have some sort of information to derive, we will work with the right custodian agency as well as the domestic Ministry of Communication with Yoshikai-san's offices to work with more close relationships, how to utilize those information for the indicators. And then, for example, 14.1.1, as you can see right down below, this is a little bit the progress for the coastal eutrophication. We have a right partnership with the Japanese, community, so in order to utilize the best way for this, ocean coastal data sets and by the satellite data. You see, satellite data captures about a wide area. And then frequently, so this satellite typically captures every 2 or 3 days for the same areas, so that our ocean data sets can be provided such kind of frequent data sets. So this information should be utilized for this monitoring for the 14.1.1. Could you please go to the next slide? One more. And come back to one. So yes, according to the 15.4.2, as Yoshikai-san already mentioned, we have already close tight with Japanese government, Ministry of Internal Affairs and Communications, and try to make most utilized cases by our satellite data to the mountain green cover index. So as you can see this image, JAXA providing a high resolution land cover data. You see color differences about the urban area, water areas, and the mountain index, and so on and so forth. So this information is going to be provided as a base information for the mountain green cover indexes by using this Earth observation satellite data. And then we have already conducted about some sort of comparison between the FAO estimated MGCI and as well as JAXA produced about the MGCI, and then we have a highly coincident result has been happened already. So that ministry people and some JAXA as well as some technical expert people are getting together to try to summarize to produce about the guidance document for the further use of this result. So this is a typical progress on this point. So next slide, please. So that's all I have for the JAXA contribution to the SDGs indicators at this point in time. And then we are preparing for the panelists about those 6 questions. And then question number 1 is most general. In your country using or trying to use Earth observation data in the development of the official statistics for the SDGs in monitoring and reporting to the UN? If so, which SDG indicators? What kind of Earth observation data is used and how? So this is this question, and the answer should be included in your presentation for the next 3 panelists. And then during the panel discussion, we are going to discuss picking up from question 2 to question 6, maybe some sort of a modification of the questions and the further detail to be asked to each countries, and also the Gemma-san as well. So, and then hope, as Gemma-san already mentioned, please, from the audience, we would like to welcome any question from the audience, and then so that please use the down the bottom question and answer function, and you can write the question so that I would like to pick up some of them for the panel discussion. So that's my presentation. So that I would like to move on to the country use case. I would like to introduce Ms. Jamaria Jahar from the Malaysia, head of the Big Data Analytics Department of the Statistics of Malaysia. So Ms. Jamaria, floor is yours. Please.
Thank you, Mr. Chairman. I will start my presentation today with an overview of SDG initiative in Malaysia. Malaysia has committed to implement the Agenda 2030 for Sustainable Development at the UN Sustainable Development Summit, New York, on 25th September 2015. Malaysia's involvement in the development of the SDG at the international community began in late 2014. In July 2015, the Department of Statistics Malaysia was officially appointed as the focal point to coordinate the SDG data collection from various ministries and agencies. In September 2015, the Department of Statistics Malaysia was appointed as a member of the High-Level Group on Sustainable Development Goals at HLG SDG, and meeting representatives of Malaysia and the Asia Pacific region. Department of Statistics Malaysia has published the initial assessment of the SDG indicators for Malaysia 2018, which presents preliminary assessment of the availability of data for 244 SDG indicators in Malaysia. The first report, SDG Indicators Malaysia 2018, was published in 2019, and 99 indicators were identified as available. Currently, the second report, SDG Indicators Malaysia 2019, was published in November 2020, which identified 128 indicators as available. Therefore, Malaysia has achieved a better level of indicator availability with the addition of 37 new indicators and 18 indicators at the district level. This in turn will help in the measurement and monitoring of the SDG at the local level area. For the purpose of disseminating and sharing data related to SDG, Malaysia has launched National SDG Progress Monitoring System, which is SDG Dashboard, in March 2019. So, for the first question, whether EO data is used in the development of official statistics for SDG monitoring, yes, Malaysia has 2 projects regarding EO data. Department of Statistics is actually started to use Geographic Information System technology since 1991 census and widely used it during pre-enumeration for 2010 census. Over time, the use of GIS has improved in line with modernization in 2020 census, where DOSM has developed DOSM Smart Listing and DOSM Smart Map and Malaysia Statistical Address Register. Subsequently, DOSM has embarked a study for identifying living quarters in remote and inaccessible areas using satellite imagery as a complementary system to DSM module. So, which SDG indicators relate to this exercise? We agree that this exercise relates to SDG indicator 17.19.2, which is proportions of countries that have conducted at least one population and housing census in the last 10 years. In this project, we have a next slide, please. In this project, we have a strategic collaboration between Department of Statistics Malaysia DOSM and Malaysian Space Agency. MISA provides us with latest image where the images were captured every 14 days with 1.5 meter and 0.5 meter resolution. So the advantages of this project are it assists in identifying living quarters in remote and inaccessible areas using satellite imagery without having to perform field operation. Indirectly, it will save on field operating costs and provide an effective and efficient platform in enabling the compilation of SDG indicators, especially during the COVID-19 outbreak. Next slide. Okay, for the second project, it is still in the initial stage where we're trying to estimate Malaysia rubber plantation area and productivity using satellite imagery and machine learning. In conducting this study, DOSM has participated in the ONS UNECE Group for Machine Learning 2021 project. We also have a strategic collaboration between DOSM and Malaysia Space Agency MISA and Malaysian Rubber Board. The advantage of this study is to identify new and potential approach to complement and or to replace the traditional data collection method that is presently applicable in rubber production monitoring and estimation. With that, I end my presentation. Thank you.
Thank you very much, Mr. Jamaria. It was a really impressive presentation that I've never known about Malaysia has such a very advanced system already exists. So thank you very much again. So interest of time, I would like to move on to the next presenter, Miss Voltia Jamboldolju. So she is a statistician, National Accounts and the Statistic Research Department, National Statistic Office of Mongolia. So welcome to the Volturia. So floor is yours for presentation.
Thank you, Asama-san. And good afternoon, everybody. My name is Volturia, and now I will talk about Earth observation data in development of official statistics for SDG in Mongolia. And firstly, next slide, please. Okay, firstly, I would like to give brief information about geospatial statistical development at the NSO Mongolia. Geospatial information system was first introduced in NSO Mongolia for the 2010 population and housing councils and used through all the stages. Since then, we have been using GIS for the all councils such as population housing councils, agriculture councils, and business establishment councils, etc. Before 2010, we used the geographic information and statistical mainly served as planning and monitoring tools in the forms of road drawing and basic cartography. And the development of GIS at the NSO Mongolia brought interagency government collaboration to the next level. And now currently we are developing geographic information system through the Smart Government project. It's going to cover all statistical sectors to the ArcGIS server. And here is the link, you can see it. And next slide, please. And so next slide is about experimental estimation for SDG indicator 9.1 and 1. And we did this estimation in 2018. And we used ArcGIS desktop Earth observation software. The data sources we used is road data and population and household database. And how we did this, and so the first we selected road, which is used in all season, and then we estimated 2 kilometers buffer zone from the road, and which is we find 2 kilometers away from rural and central road network. And then we showed the location of household by points, and then identified households located in 2 kilometers buffer zone, and estimated total number of rural population located in 2 kilometers buffer zone. So then we find the estimation and we get the outcome from this. And but there was a huge challenge, and unfortunately, the missing road data is very much in this situation. So also in local Mongolians are still nomadic, and because of that, some households changing locations and moving from locations to another location in seasonally, and that was the big challenge. And missing road data is very hard to and confusing. And next slide, please. So in NSO, we think that integrating geospatial information and statistic databases is crucial for SDG implementation for modern evolution. So we are now trying to develop a geographic information system, as I mentioned before. So for example, we can see the example from the indicator 7.1 and 1, and in the slides we can see the electricity network and lighting system in one of the districts in Ulaanbaatar, and we can find here that over 1,000 households to meet the criteria, and that households connected to the electricity. But we can also see that some of the households is still not access to the electricity. So I want to say that this GIS, geospatial statistic database integrated, so we can use the decision. We can use disease for the decision making. For example, where and when we can access the new power lines, or where and how many households we should access to the electricity, etc. So this is very important for decision making, I think. That's the end of my presentation. Thank you for your attention.
Thank you very much, Tia. So nice presentation. And I understand that maybe if I'm wrong, please correct me. I think Mongolia you have not yet used about Earth observation data clearly, but you surely starting clearly for the ArcGIS and GIS information system have been already used. So that I think Mongolia has just a starting point to try to incorporate lots of expectation to be there, I think, so that this is a nice engagement for the starting point. Thank you very much.
Thank you.
The next presenter is Miss Litia Krisakila Mate, Assistant Statistician, Economics Statistics Division, Fiji Bureau of Statistics. Thank you so much for coming. The floor is yours. Litia, are you online and you are muted?
Sorry. Yes, I was muted. Good afternoon, good evening, everyone. I'd just like to take this time to share briefly with you my experiences in compiling Fiji's experimental land cover accounts using Earth observation data, namely satellite imagery data. Next slide, please. So for Fiji, our NSO came about using Earth observation data as a result of compiling SIA accounts, which is a system of environmental economic accounting, which we started doing in 2016. So in determining which accounts to produce in the SIA framework, we consulted our national document, which is called the Green Growth Framework, which highlights the country's socioeconomic and environmental concerns, together with short-term and long-term strategies to help address those concerns. In doing this, and also consulting with our potential data custodians, we decided to begin compiling land cover accounts. So in tackling the land cover accounts, we would be able to provide some data to help inform users on issues about sustainable land and ocean resources, which were addressed in the Green Growth Framework. So in linking that land cover to SDGs, we saw that producing this land cover account, we could also partly inform some of the SDG indicators in terms of reporting not only at a national level, but also for reporting at a global level. So for example, from the land cover account, the rate of change for forest cover, urban areas, and agricultural cover, we could inform reports on targets and goals for SDGs 15, 11, and 2, just to name a few. So this account can either in part or fully help to measure some of these indicators, taking some of the pressure off those who have to report on these indicators every so often, like our colleagues in the Department of Environment, as well as the National Planning and Foreign Affairs offices. Next slide, please. So the approach we took was a pragmatic one, since we did not have the locally sourced data that we initially wanted. Our consultants who were helping us with this project, Mr. Sohail Rastan and Alahad Musnuru, suggested that we use globally sourced data, which is available to the public via the European Space Agency website as part of their climate change monitoring program, I believe. So we used these SM maps, which was medium resolution, 300 by 300, for the period of 2005 to 2015. We used QGIS software, as this was open source and readily available to us. And for the analysis bit, the consultant suggested that we use SEN method of regression, which I understand was more simple to compute, robust, and limited assumptions regarding measurement errors. And we used the SEN template from the Finnish Meteorological Institute, which I found quite user-friendly as a beginner who wasn't really a technical person on things like GIS and mapping. So in validating our results, we had done quite a lot of stakeholder consultations with respective ministries that could help inform our land cover count better, namely the Forestry, Agriculture, and Ministry of Land and Mineral Resources. Next slide, please. And so this is a brief summary in 10 steps of the process of training that I had gone through with our consultants, given the support from SCAP as well. It goes from downloading the software, extracting from global databases, reading in data, processing it to generate the different land cover area, to the analysis and using the template from the Finnish Meteorological Office. So we had released an experimental release showing our results. However, we concluded that we needed a bit higher resolution data to produce that last step 10 there, producing the land cover change matrix, which we hope to do once higher resolution data would be available to us. And on that note, I would like to end my presentation. Thank you very much for listening. Naka.
Okay. Thank you very much, Rita-san. So nice presentation. You have already engaged with the SCAP as well for the methodology. And then you already started about the data acquisition, processing, and analyzing those indicators already. So this is great. So thank you very much. So thank you all those presentations. And then now we are going to the discussion, so that I would like to moderate. So coming back to the questions again. So for the listed here about the question number 1 and number 6. And then those you have already answered question number 1. And then I recognize about there are diversity. You have several progress differences, several indicators differences, and then so on and so forth. So that it's quite diversity world for the SDG indicator implementation. And then it's hard to try to converge everything together, but I think it's a diversity world. So my first question may be to Malaysia, because you have some already a progress about SDG indicators, productions, and then analytics things. So I would like to focus on question number 2 and number 3, because you already have some lessons learned. So what do you think is important in utilizing Earth observation data for SDGs indicators? What are your good practices? And maybe also the lessons learned for the Earth observation data utilization and the compiling SDG indicators. So it's a bit, general question, but please answer if you have any insights on that. Thank you.
Okay. Thank you, Mr. Chairman. Earth observation is seen as one of the main sources of data in compilation of official statistics and needs to be integrated in the compilation of SDG indicators. So EO data has to be shared among the relevant agencies. It provides tremendous opportunity to be used as reliable input and contribute to more efficient and knowledge-based decision-making process. EO data can be used in a wide variety of ways to improve social support system and planning. Geospatial information integrated with planning, census, and other social information enable efficient and effective allocation of facilities and resources. Many countries already use this data for infrastructure, town planning, telemedicine, and teleeducation, and poverty mapping. Therefore, We should leveraging new source of data and administrative data to improve the quality of data in producing official statistics. For the lesson learned in using Earth observation data, in my opinion, firstly, partnership, trust, and governance are essential. There is a need for platform and channels that facilitate communication among statistical community. There is a need to deepen relationship with data providers and users in order to get continued feedback. It is important to enhance resource capacity through the establishment of centralized governance for the implementation of the agency Emerging Technologies Initiative. We should accelerate the implementation of emerging base initiative technologies among public sector agencies. The advantages of using EO data, such as the images from satellite, is to produce and support official statistics to complement traditional source of socio-economic and environmental data. Satellite imagery will be perhaps the only cost-effective technology to be used and able to provide data at global scale, especially during the COVID-19 outbreak. That's my opinion.
Thank you very much, Jamalia-san. So your very, comprehensive answers try to cover everything about that. So this is great. I think Malaysia case is quite the best practices that can be also propagate to the maybe Mongolia and maybe Fiji and maybe of course other country. To that is quite a good opportunity. AOGEO can provide further to propagate your best cases to other countries. So I would encourage, and then you stay on in AOGEO, and then please, emphasize your best practices to other countries. So that's my, recommendation. So go back to the question. I think yes, I recognize about different progresses of the indicator production in Mongolia and also the Fiji. Maybe I would take slightly maybe a difficult question answers for you, but the question number 4 and number 5, how can Earth observation contribute to SDG in general, in your opinion? First of all, maybe Mongolia, Voltaire, do you have any opinions about expectations for the Earth observation contribution to your country in SDGs?
Okay, so in my opinion, Earth observation can contribute to SDGs from the two sides. The first side is related to producing indicators and monitoring indicators. I would say it can help populating data gap to the different data sources. Other side is showing social, economic, and environmental situations by locations. So Earth observation combined with demographic, statistical, and other data. So Earth observation can be used for action and data-driven decision-making across the government and maybe support the targeted development programs. I think the collecting socioeconomic data can be very expensive and time-consuming to monitor all over 200 SDG indicators. So Earth observation can be contributed to reducing cost effectiveness, I guess. However, satellite data can be maybe expensive too. So here I would say it's more suitable for areas that environment and climate change or disaster risk reduction related SDG indicators such as goal 1, 6, 11, 13, 9, and 1, etc. And I think we are like we're expecting the further collaborations of methodologies because the uncertainty of methodology is very confusing, and So we are expecting that all other countries and GEO and AOGEO can help by providing certain methodologies and sharing best practices is helpful also. Also, maybe training human resources in order to developing skills to using Earth observation data or tools will be helpful as well. We will appreciate if you providing consulting services as well too. And I think this symposium is very good example for sharing experiences too. I really appreciate it, and thank you.
Thank you for your very productive opinion. So this is all I think Geo can coordinate, but yes, we need some sort of very light way to do so. So otherwise, people are going to a long way. So, but thank you so much for your request or maybe opinions for this. You have very much expected to utilize for the Earth observation to try to make a cost benefit. Statistic information to be produced in future. So thank you very much. So Rita-san, so I would ask maybe the question number 5, because you already have a planning to utilize Earth observation data sets. And then maybe this is a somewhat repeated question, but you mentioned about, you refer to the SCAP methodology and try to utilize the ESA European data sets. And then how are you planning for those data sets to monitor? Because you didn't indicate about the SDGs indicators, but you only mentioned about the goals. Are you trying to monitor some certain indicators by using for the Earth observation data? So this, I'm just asking about the more general, your feeling about what you are missing, what you're planning, and so on and so forth. Just welcome any other opinions. Thank you.
Yes, so like I had mentioned initially, our goal was to compile SIA accounts. But in saying that, we also knew that there were advantages in compiling also form SDGs. So I think it very much goes hand in hand by compiling one, by doing one framework, which is SIA, it can help inform SDG goals and indicators, by doing our land cover count, some of the things that we get from it, like rate of change for forest cover, we could, look at, for example, indicator 5.1.1 forest area as a proportion of land area, or looking at goal 11 in terms of urban areas, a ratio of land consumption rate to population growth rate, or even goal 2 in terms of agriculture, proportion of agricultural area under protective and sustainable agriculture, which is, I think definitely what we plan to do with the EO data is to continue to develop SIA in the hopes that by doing so, we will also be able to help inform these SDG indicators in terms of using how we're gonna use it. The only thing we can do right now is let our the work that we're doing to help inform their reporting and monitoring process, so to speak. Yeah.
Okay.
Did I?
Sorry, Rita-san, I think the line is a little bit congestion, so that we cannot hear everything from you. But I'm sorry, just I would like.
Oh, okay.
No problem. Thank you very much for your comments. I would like, so the interest of time, so we need to stick the time for the ending. So I would like to just invite Gemma-san again, just in hearing from those 3 countries, what SCAP, because you mentioned about a lot of things still lacking about the progress of the SDG indicators. So what do you feeling about hearing about the situation of 3 countries, and what SCAP maybe can do to try to improve with GEO and framework? So that kind of thing. So could you please go ahead? Thank you.
Yes, thank you very much, Mr. Osama, and thank you very much to our 3, well, actually we had 4 speakers from National Statistics Office, the Statistics Office of Japan, Fiji, Mongolia, and Malaysia. And look, I think the diversity, what can we do? Well, I think what we need to do is recognise that the 2030 agenda is a country-led agenda, and it's up to countries to prioritise which of the indicators and which of the goals are most important for them. And as you see from the 4 presentations, each country is looking at different indicators and looking at different goals with different priorities. So in the case of Fiji, land, goal 15 was important. In the case of Mongolia, 9, access to roads was very important. In the case of Malaysia, they're actually got several goals of importance, and in the case of in Japan, we'll also see not only 15 and 14 life below land, but several others as well. So to me, this one lesson is that we can't, so therefore we have to provide a variety of options to people. So having events like today that showcase what other countries are doing and what other tools and facilities are available is really important to countries. The second observation that we just heard from both Fiji and from Mongolia is that having access to data that's already available and methodologies and tools that are already available is very important. A lot of the statistical officers don't have a lot of resources to buy data or to buy tools. So the open access tools like QGIS or the freely available data like we heard from the European Space Agency is extremely valuable for testing methods, for testing compilation of the SDG indicators. But then very importantly, as we just heard from Fiji, if the resolution's not sufficient to get quality statistics, then they'll keep working on this until the sufficient quality is there for the purpose, in their case, green growth, but also for the purpose of the government reporting into the political processes of the 2030 agenda. So to me, the expectation, and again, so in summary, I think, you know, the value that events like today and the value that organisations like the United Nations and GEO bring is that we can convene conversations like today, we can share examples, and we can provide tools and guidance on what is possible, what other countries are doing, and here's some examples of how you to do it. So don't underestimate how much powerful that is, just to share examples, share best practice, and share ways that people can access Earth observations data and tools to use those. That would be my reflection, that the National Statistical Officers really do value from the Earth observation community these very good events and examples. Thank you.
Thank you very much, Gemma-san. So we need to close the session. Unfortunately, we apparently lack of the time. We don't have, we need more time to discuss. You raise a very important topics like the cost things, like a cost for buying Earth observation data is certainly a big issue in GEO as well. We need more freely open data sets, tools, and services, and so on and so forth. That is a huge topic to discuss. So, and then Mongolia and Malaysia, Fiji, you all raised that kind of topics as well. So that we recognize, we like to note about this. And then, sorry, just we don't have time to discuss about what QA information. Laurent Duriot, he is a new GEO Secretary SDGs officer and from France. So thank you very much for your comments put in. And then certainly we all agree about the strong dialogue with country stakeholders and other stakeholders for supporting for implementation, as well as using a toolkit just presented by the AOGEO from the EO4 SDGs is certainly a very supportive, important topic. So just summarizing of this session, what I would like to just point it out is because this is the first time of this special session for SDGs and GEO. So apparently we need to continue this type of session discussion in future. So just let's keep moving, let's keep this dialogue in the future as well. And then hopefully the next time we can discuss a more concrete, more practical, maybe project-wise, or maybe some sort of a support, pilots and so on and so forth. So just I'd like to just emphasize about let's keep doing this conversation in the future. So I would like to come back to Gemma-san for your closing remarks. Thank you.
Wonderful. Oh, thank you very much. It's been an absolute pleasure to co-host this with you and with AOGEO and the broader GEO community. Like I said at the start, you know, it's really, you have so much expertise and willing to share that expertise in events like this. It's really greatly appreciated. To the organisers of AOGEO, thank you for all the preparations. Thank you for reaching out to the statistical community to host this first session. And I hope it's the first of many over many years and decades of symposiums that the two communities can come together and share our experiences and observations. So with that, to all of our participants, I think we peaked at about 120. It's been great joining you this afternoon or wherever you may be joining us from. And I look forward to the rest of the, please stay away, three days for this really great symposium. And I do encourage you to make use of the 3 days of the symposium and the expertise that will be shared with you over the course of that. With that, it's been a great pleasure to be a co-host with you, Mr. Osama, and I really do appreciate again the opportunity to be with you here today. Thank you very much, everybody, and have a great evening, great afternoon, wherever you may be, and we look forward to seeing you again soon. Thank you very much.
Thank you.
Thank you.
Thank you very much.
Thank you.
Thank you very much, Gemma-san and Osamu. And thank you to all the participants for joining. And thank you to the speakers for nice presentation and sharing your thought. So I want you to do me a favor. If possible, I want you to turn on your microphone and give them a big applause. Thank you very much. So before we close the symposium day 1, I have one important announcement for you. Because this is online symposium and we can't take a group photo. So we kindly ask all the participants to send us your photo. You can take the photo now, or you can send us an existing photo or old photo, whatever. Then we will mosaic those photos and create a group photo. So please send us your photo. And this is all we have today, but AOGEO Symposium will continue. We will have status report of AOGEO activities and the special session 2 tomorrow. So the symposium will start on 3 p.m. in Japan time, exact same time as today. So please make sure the start time in your time zone and come back. Once again, thank you very much for your participation and see you again tomorrow.